Hello everyone. Uh, Today I will be presenting the lecture on agent-oriented software engineering. That will give you an insight about what actually agent and objects are and how they are being differentiated. It tells about the know-how about how agents are more intelligent as compared to the normal object, and how you can develop and design a software known as agent-oriented software, which is intelligent enough to take its own decision. So coming back to the presentation, uh, the requirements for agent-oriented software engineering is that software engineering is very, very reliable, as and it is used in various domains as a tools, but it has got certain limitations. The limitation is that the object cannot send and behave according to the environment or adjust according to the environment. So what we have to do, we have to make the objects more and more capable of interacting with the external environment and behaving it as and when required. Here comes the role of agent. The agent is based on novel idea of abstraction, where the agents can behave in a way that they can accommodate with the environment and response according to the environment. That is the key factors. Now, in the third slide, we are going to see what is the key software engineering agent characteristics, or how we can define an agent and differentiate it from other things like objects, right? So point number one is agent-based solutions cannot be applied in every situations. For example, if I am designing a firefighting robot, right, it has to support only firefighting situations, not every situations. For example, if I am having a washing machine or intelligent washing machine, then all the programming of the agents or whatever agents we have developed is only focusing on agent behavior of washing machine. So they are developed for a specific use and with a specific properties, right? So, and for a specific applications that is given in the second point. That is, as the application is needed, it is designed for that purpose only. While the software agent can be defined as a computer system located in any environment, which acts on users' behalf and is characterized by various properties. For example, consider the case of a washing machine. What we have in washing clothes, we need three factors in case of washing machine. There are three variables. Now, the agent should be intelligent enough as soon as we put our clothes in the washing machine. It should be able to distinguish from the weight of the cloth that how much detergent is required, how much water is required, and how much time it will take the drum to spin and generate an output of washed clothes. So all these variables has to be decided intelligently by the specially designed software agent for the washing machine for a specific purpose of washing clothes, right? So we are having, and it is behaving on behalf of human being. If suppose there is no washing machine, then you would have washed it according to your own uh, thinking or experience, you can say. That experience comes from the perception. If you keep on washing clothes daily or maybe alternate days, maybe on the first day of washing the clothes, you may have wasted water as well as detergent. But for the second time, if the same level of clothes are there, you will be able to distinguish that, okay, now this much water is required and this much detergent is required. You don't require much of the detergent as well as water. So this is how we are intelligently eliminating the need of human being in the machines and making the machine more and more intelligent enough, right? So uh, the major concept in the definition which was defined was adapted are the autonomy. As I've told you in my previous slides, that autonomy is very essential part when we are designing a software agent. That is, it should be able to behave and act on its own. Secondly, if there is another agent or a collaboration of various agents, then they should be able to communicate each other in a particular agent protocols, right? That is, they should have the social ability, right? Then comes the reactivity, that is reactiveness. As soon as something happens or some signals are given from the environment, they have to reciprocate in the same manner for which they are designed for, right? And lastly, the proactiveness, that is, they should be able to behave in advance by thinking that this event is going to occur, right? So as soon as the event occurs, they are able to accommodate that, and they are able to very well deal with that, like we humans do. For example, I have told you about the storm, where if I'm having an intelligent window, then the storm will be automatically closing the agent will be automatically closing my window, right? Right, thereby preventing any dust or storm or rain water, right? Last point, intelligent agent defines as one that has autonomy and enjoys having it. It is also emphasizing on the components like veracity, that is how fast it can process; rationality, that is they should behave for what they are designed for; then learning, mobility, and benevolence, as I have told you in my previous slides. Now coming to the agent language. For this, we have a model known as BDI, belief, desire, and intention. First of all, the agent has to believe that the thing is going to happen, then desire, then an intention. It will result into an outcome or performing some activity. You can see from the figure that uh, we have belief in the first instance, and the goal in the second instance, and intentions in the last instance, right? Now belief has to be designed in terms of the cognitive agents. Cognitive means thinking ability, which is based on inter-agent communication and coordination, that is the agent are behaving in a social responsible manner. Secondly, the input output which it received from the sensors, right? So this is basically relative to reactive for producing timely response, and behaving to the external stimuli. Then deliberative for processing learning and reasoning ability. What is the meaning of this? It means that it has got a learning ability as well as reasoning ability. Reasoning is being developed by writing a rule set, by using the concept of if then else that we all have seen in our programming. You generate a rule base based on if then else statements. If the water in so and so and the cloth weighs 6 kgs, then water level should be this much. like that in washing machine. Like that we can design for any systems, right? This is known as reasoning ability, which we embed in the intelligent agent. Then we have a reflective agent to continuously measure and adapt with the introspection mode, right? For example, if it is processing in a real-time mode the temperature of the room, such that I have to detect whether if there is any fire or not. So it has to be working in a continuous mode. Say every 15 seconds it has to send a signal to the control center, where the control center will be processing the information, and as and when required, it will be working accordingly. That is, it will be raising an alarm, or a sprinkler is being turned off on. Although BDI model is very useful, I have told you last one, the university case as well as the firefighting robots. I have dealt with two cases earlier in my previous slides or lecture, but they do have certain limitations. These limitations are being overcome by using the various other paradigms, that is the technologies which we'll be using and discussing in near future, right? And it will depend on how easy we can design or develop any software agent. Agent orientation emerges as a new paradigm for the construction of software systems. Newer system types are getting developed as per the concept of software agents. Software agents are located where they sense environment. They are autonomous and have the control of the actions and state of internal, and can act with no straight intervention from the people. That is to say that they have autonomous capability. You don't have to again and again program your washing machine or your firefighting robot. Once you have put your clothes and you have turned it on with putting some detergent, right? Now it will automatically take the level of detergent which it wants, as well as water, and it will decide based on the weight of the clothes. No intervention in between is required at all, or no human interface is required at all in between, right? Once it is programmed, once you press OK, go, right? Then it goes on its own. There's no need of any interruption or interaction with the agents, right? So the agent model is divided into two basic concepts, you can say. That is the social level viewpoint, and the second is knowledge level. Both are equally important. I'm repeating that both are equally important from the designer's perspective. No level or no two categories can be separated or segregated. Whenever you are designing, you have to think about the knowledge level which you are going to embed in the agent, as well as how the agent will be responding with the other agents. You cannot have an isolated mode. It has to have certain type of communication or sending of the signals back to the control center. So we are having basically 5 levels in which we can divide knowledge level as well as social level. Equating it with the middle level, you can see here. You can see in the diagram in the middle part, that is this part, right? You can see that this is the part of the agent, right? This is the part of the agent, and these two, this is point number 2 and this is point number 1. Point number 1, these two are collaborated. These two are collaborated to develop effective features of any agent, right? First of all, we will be seeing the knowledge level. The knowledge level deals with the agent itself, designing of the agent. How much knowledge you want to embed in the agent. Then what are the goals which the agent will be performing? And what are the various types of set of activities which are responsible for occurrence of the particular agent? And they should behave in a principle of rationality. They should behave in a principle of rationality. That is, they should behave in whatever manner they are designed for. Right. Then the last one is the knowledge which we want to embed. This is using the concept of rule base. Okay. This is using the concept of rule base. Rule base, I have told you that it is dealing with the concept of if, then, and else, right? If then else concept. Now coming to the social level part, agent organization. Why we are saying that it is an organization? Organization means this is one agent, this is one agent, this is one agent, this is another agent, this is another agent, right? Now there should be some medium by which they should be able to collaborate with each other, right? That is why this holistic picture is nothing but an organization. Then how this agent A1 is related to this agent A3, right? This has to be taken care. Then what are the roles in the organization? What are the role? Suppose that we are designing a smoke sensor or a firefighting system in which we have three factors. One is what? Fire alarm. One is this fire sensor. The other one is fire sensor. Second one, temperature sensor. And third one is the sprinkler. Right. Now, first it will sense the temperature rise, right? The temperature rise, and then it will be communicating to the fire system. The fire system, on sensing that the temperature is rising at somewhere very fast rate, that is delta T is very, very high, that is rise in temperature, it will give this command to the sprinkler, and sprinkler will eventually start and extinguish the fire. So all these things are related with the social structure also. Here we, in social part, we are dealing with the word commonly known as organization, right? While as in this we are talking about the autonomy part of the agent, right? This is what we have told you previously. Now coming to the basics, where we can collaborate is the summing up the entire thing. The agent-oriented software engineering is nothing more than a device, or you can say a method by which we can design a system which is capable of removing any ambiguity in the design prospects, as well as in the developing a particular system. They are generally used for designing a very complex system where the concept of agent object has certain limitations. It consists of both the things like hardware as well as software, right? It is having certain design languages like Prometheus, Gaia, which we will be seeing in the next lecture. Okay, that was enough for today.